Let us try to understand the another type of regression, that is lasso regression. Lasso regression is defined like here also, loss function, some loss function. Again loss function, we have to remember that difference between the actual value and the predicted value. Predicted value, actual value, some loss function, and we are trying to add some penalty. This is important here. Here any loss function we can use, the loss function plus some penalty. Here some penalty is alpha into L1 norm we are using. That's why it is 1, because it uses the L1 norm. L1 norm is nothing but the absolute value of all coefficients we are adding. That is W1, absolute value of W1 plus absolute value of W2 plus absolute value of dash dash Wn. So all the weight values we are adding, and we are multiplying that by alpha, some parameter, some constant that can have the value between 0 to 1, like like we have seen in the ridge regression. So this gives us the lasso regression. An alternative expression can be like actual input, actual output. This is actual output, predicted output. Difference between that is nothing but a loss, and this alpha here lambda represented by lambda. W is nothing but a theta in this case. So either this expression or this expression we can use. In different books, different expressions are used. So as per our book, we will go with this expression. So lasso regression. So you see the lasso regression. So what happens for the different values of the alpha here? Suppose if you consider the value of the alpha equals to 0.05, again the same example we continue for that we have used for the ridge regression. Here these many input variables are there. For each input variable, some coefficients are learned. Whenever we set the alpha equals to 0.5, then that coefficient values are again, in this case they are reduced. The coefficient value is like this here for the alpha equals to 0.05. So it is very much sensitive, I will say. It has a very larger values for the 0.05. If you make it as a 0.05, then these values are reduced. See here, it was nearly some 1900, we can say. It is reduced to some 1800 or 1700. Some values are reduced, but some values became nearly 0. If you see, many values have become 0 here. And in this case, again, so many values have become 0. So this is the difference between lasso and ridge. In case of a ridge, coefficient values tend to near to 0, but they are not 0. But in case of a lasso regression, many of the coefficient values becomes nearly or they becomes 0, exactly 0. So some features are directly eliminated. Means coefficient have become 0. It means when we are multiplying that coefficient with that particular feature, means that particular product becomes 0. No, means that features are not at all considered, because that value anyhow it is coming 0. And how many coefficients are remaining here in this case? Only 3 coefficient, first, second and third, and again I think 4th coefficient. Only 4 coefficient values are remaining out of so many input variables. So only 4 input variables will be used, and their corresponding values will be multiplied by these coefficient values to calculate the predicted output. Therefore, lasso is used for the feature selection also. So here the conclusion for the lasso is, so we can see that even at small values of alpha, the magnitude of coefficients have reduced a lot. So by looking at these plots, we can figure out the ridge and difference between the ridge and lasso. So the ridge has some coefficient values near to 0, but in case of a lasso, many coefficients have become the 0. That is the difference. We can't see that as we increase the value of the alpha, the coefficients are approaching towards the 0. Here in both the cases, they are inversely proportional. Coefficient values are inversely proportional to the alpha. But if we see the case of lasso, even at smaller alpha values, coefficients are reducing to absolutely zeros. Therefore, lasso selects the only some features while reduces the coefficients to others. This property is called as a feature selection. Again, I want to explain that why it is called as a feature selection. Suppose, as we know that regression is nothing but this y predicted equals to some alpha 0 plus whatever. Suppose our data set has the 5 features, then we write here alpha 1 x1 plus alpha 2 x2 plus alpha 3 x3, then alpha 4 x4, then plus alpha 5 x5. So suppose this is the linear regression in our case, because we have the 5 features. Through the training, we learn the value of these coefficients. We learn this value of the coefficients. Suppose we have learned the coefficient values like this: 0.6 plus 1.3x1 plus suppose then 5x2, then 7x3 and plus suppose 19x4 plus then 25x5. What it tries to do now, these coefficient values are learned. 25x5 you consider, these values are learned. So after applying lasso, what happens? Whatever the coefficients are there, these coefficient values, that is 1.3 or 5 or 7 or 19 or 25, it tries to reduce the coefficient values. In both the case, reach as well as lasso, these coefficient values are reduced. Suppose 1.3 might become 0.6 or 5 may become 2, 7 may become 3. So values are reduced. But in case of reach, it reduces to some extent. Some values become nearly to 0, but in case of a lasso, some values are directly becoming 0. Suppose this value becomes a 0 and also this value becomes a 0. What happens? 0. This equation becomes like 0 into x1 plus 0 into x2 plus 7 into x2 or 7 may reduce to the 2. Suppose 119 may reduce to the 9 x4 or plus suppose 25 may reduce to the 5. Suppose this is the after applying that lasso regression, this happens. So some values become 0. It means these values we can rewrite this equation: 0.6 plus 2x2 plus 9x4 plus 5x5. It means to calculate a y cap, here it is a y cap. To calculate a y cap, how we are calculating y cap? Y cap is calculated based on x2, x4 and x5. And completely x1 and x2 are ignored. It means they are very less important features. Therefore, that features are removed here. So always y cap is calculated based on x2 because these are the important features. Which is the more important here in this case? The coefficient of x4 is more. Therefore, x4 is very important. Next, x5 is important. Then x2 is important. So always lasso tries to reduce some of the feature coefficient values to 0. It means it tries to it does the feature selection. It removes some feature and it keeps some feature. But in case of a reach, it never removes some features. It reduces all the coefficient values to very smaller values. But in summary, in both the cases, in lasso as well as in reach, both are trying to reduce the coefficient values so that our calculations become easier. Here in this case, in case of original, we have to multiply each x2 by 7, each x5 by 25. Any test pattern, suppose record is given, then this value attribute values we place and we calculate for that record y cap. No? So for each test sample, we have to do this many multiplication by big numbers. Instead of that, if you are multiplying by the small numbers, then the model complexity gets easier. Thank you. So this is the purpose of a regression.